Welcome to Knowledge Series. Here under the course EC407 Computer Communication, we are going to discuss in the area of QoS, that is quality of service. So what exactly the quality of service means? Quality of service, it refers to a broad collections of networking technology and techniques. The goal of QoS is to provide a guarantee on the ability of a network to deliver a predictable results. Elements of network performance within the scope of QoS often includes the availability, uptime, bandwidth, throughput, latency, delay and error rate. That means when we talk about a network QoS, it tries to look for the network traffic and how it has to prioritize that packet towards the networks. So QoS can try to look for a network performance in terms of availabilities, in terms of a bandwidth, in terms of a delay, and even in terms of a error rate, so that if all these things are taken together, it will improve the performance of the router with respect to the application. So a network monitoring is very essential in the case of a QoS, so that the performance can be measured. So the basic QoS concern is to characterize the network connections of the network service provider. Those means if you take say Airtel, so how the Airtel will try to provide the better service with respect to the availability, bandwidth, latency and error rate, so that the network corrections can be characterized in terms of all these network performance attributes. So QoS basically applies for the whole network connections. So with respect to this, we will be looking across some of the sections related to QoS. The very first thing is the need for QoS. What is the necessity of this QoS? If you look across the video and audio conferencing, it needs a bounded delay and a loss rate. Bounded delay means there should not be a heavy more delay, and there should not be a more loss. Of course, there will be a small delay can exceed small loss of the packet can exhibit. So that should be under the bounded condition. In case of a video or audio streaming, it also requires that there should be a bounded packet loss rate, so that it may not be so sensitive to the delay that appears on the video screen or on the audio hearing. Time critical applications, that is a real-time control application, the QoS plays a very important role. So that's why a bounded delay need to be considered. Apart from that, suppose there is a specific applications, say space launching. So under that condition, a better services with a less vulnerability of the above performance measurement components should not deviate. So these are the things with respect to the QoS in the networks, because when we talk about a traffic, the traffic should come under the preview of the availability, bandwidth, latency as well as error rates. Now let's see the type of the QoS parameters. So there are two types of a QoS parameters. The very first one is that let us consider that those which is used for transmitting the informations over the network. So the network service will try to establish a network connections. So establishment phase for the network connections, that should be under the case with respect to the transmitter from the sender to a receiver side. Under the transmission case, there should be a tri-parties, or we can say a tripartite, or a three entities that try to establish a connections between the network. That means two users and a network service provider. That's why it is known as a tripartite establishment. So tripartite establishment is needed because when the two parties there, the network service provider need to control these QoS parameters, that is 4 parameters which I have stated: availability, bandwidth, latency, and error rate. So these parameters need to be properly controlled. The next type is that the transmitter between you can see that the value of the that is transmitted or negotiated between the user and network service is the important components. So the QoS parameter should try to obtain the informations from the network service users as well as from the suppliers about the performance. That means when we talk about the QoS, it is not only the network, the type of the devices that we are using, that the user use the network, and also the informations that we receive from the network as well as from the suppliers, that they are using the type of the network devices in the network. So that also plays a important role with respect to QoS. So the one side we try to see that what are the values that are transmitted between the peer users and the network, that is, and another that we try to see about what are being those values which are being transmitted about this one. These are obtained these are obtained informations are from the network service provider as well as the users in terms of devices. That is also plays an important roles, because we cannot take only the network with respect to the packet, also the packet that is being transmitted between the users and the network is also plays an important roles. So that's why these two type of a parameter on the QoS try to controls the network performance. Now, what are the main QoS parameters that need to be controlled or that need to be monitored? The one is that the time of establishment of a network connections. So that is one. In the case of a QoS parameter, the time for establishment of a network connections. That means how much time it will take for a network to build up a connections for the request and then it will confirm the connections. So that is what it is. When you want to make a establishment, you first request, that is a handshaking, and after that the connection is clear to send. So that is how the QoS indicates the maximum time acceptable for the user. You try to make a phone call from your mobile, and it takes a time to get connected to your destinations. So that is the establishment phase. You don't like that establishment phase should be very long. The other one is the probability of failure of establishment of the network connections, because the probability of establishment of connections, if it is not met in the normal time limit, then we don't treat that is an appropriate conditions of the network performance. Flow data rate. The flow data rate means it defines the number of bytes that is transported over a network connections, and if it is within a short time or not, and if it takes a long time, then it determines the speed of a network connections. So that is data transported elapsed time. So the flow data transfer should also be much faster. Transmit time when transferring data. So the transmit time corresponds to the elapsed times between the data transfer request and the indicating of a data transfer. So that is the once you transmit the data, whether the data transfer is completed or not, that is what it states. Transmit times correspond to the elapsed times, that is the time it's covered between the data transfer request and data transfer of the data. Another is that residual error rates. That means a number of packets that arrives erroneous or lost or a duplicate, that is in the total number of a transmitter packet is considered as a residual error rates. Then transfer probability incident. Transfer probability incident, it is basically the ratio between the total number of listed total number of incident listed on the total number of a transfer taken. That means you are considering the say 10 packet has to be transferred. Out of the 10 packet, only 8 packet has been transferred. So that is known as a transfer probability incidence. So to have a correct estimate of the probability, considering the number of network connections related to the number of transfer that one taken place. So that is known as transfer probability incident. Another is the probability of failure of a network connections. So it calculates the number of release and resetting of a network connections based on the transfer mode. What does it means is that let us assume that your mobile is connecting to a network and during that time several base station will be nearby. So sometime one station, say A, will be accessing, sometime B will be accessing. So accessing of a base station and then switching over to the next base station, like that transfer will be there. So but because of the signal strength, if the base station switch over, so that failure of a network connection building is being stated with respect to this one, the probability of failure of a network connections. And the number of liberation of failure requires the total number of request release. So you cannot directly make a connections. There should be a handshaking, thereby it will make a connectivity. Release time of a network connections. That means this is the maximum acceptable delay between the disconnection request and the actual release. Every micro micro factor is being also considered. That means there is a disconnection request is sending. After that, the disconnection is not taking place. So that is also one factor. Priority of a network connections. That is with respect to the QoS. That means it determines the priority to access the connections of a network, and the holding priority of a network connection and priority of a data connection. So one is you are giving access to the network and then holding that network, and then your data connections, data transfer connection. All this thing is with respect to the priority of a network connections. Maximum acceptable cost. That means it determines the network connections is tolerable or not, and it depends on the resource such as establishment cost, maintenance cost, and holding and releasing of this connection network. All this thing is coming as the maximum acceptable cost. There are so many factors is determining based on determining the cost of a cost and use of a network. Protection of a network connections. That means it determines the probability of a network connections to work in a orderly manner. That means maximum throughput it can able to deliver. And protection is much in the IP network, less in the IP network, and it is around 99.9%. And this value is stronger in the line telephone connections, because as compared to the wireless situations. So that the protection on the network connections is also plays a major roles. Now coming to the flow characteristics of a QoS, there are different flow characteristics. One is reliability, delay, jitter, and bandwidth. Reliability, basically it talks about the whether you are sending a packet and you are not losing that packet, and you are making the application to run in an efficient manner. So then we say the reliabilities. That means there will be an acknowledgement, will be there will be retransmissions will be less in that case. Then the network will be finding a packet reaching the destinations without getting lost, our network is not getting congested. So these factors are related to that reliability. But if the packet gets lost, acknowledgement is not received, retransmission of the data is needed, then in that case the reliability will be decreasing. So the important of the reliability depend upon the application. Say for example, in audio conferencing or the video conferencing, this type of transmissions need a reliable transmissions than just a data transfer. Delay is another factor. Delay of a message from the source to destinations is an important characteristics, because delay should not be much, or delay need to be tolerable differently based on different applications. For example, in the case of video conferencings, smaller packet loss or a minimum delay that can be which is negligible, that can be accepted, while while the time delay in the email or a file transfer has a less importance. So the audio and the video, it needs cannot be tolerable and cannot be tolerable much. Jitter is basically the variation of the packet delays. That means one time, another time, another time, the packet processes in a different time. So that is how the jitter comes into picture. If a difference between the delay delay of a various packet, if it is large, then it is having a high jitter, and if the delay is small, then it has a low jitter. So let us take that if the 3 packet is sent, say 0, 1, 2, 3, and say 0, 1, 2, and you are receiving a packet like a 9, 10, 11, then you will find that the delay in the packet, if it is uniform, then it is accepted in the telephonic conversations. But if you are sending a packet 0, 1, 2 and you are receiving say 20, 26, 29, then there is a different delay in the packet. So in this case, time delay is not accepted in the telephonic conversations. Bandwidth means different applications needs a different bandwidth. Say video conference, it needs a more bandwidth in terms of millions of bits per second. But in the case of sending an email, just a lesser bits. So that is how the bandwidth is being determined. So that's what we talk with respect to the bandwidth of the QoS. Now we go to the next techniques to improve the QoS. So there are various techniques of the QoS scheduling, like quality of service scheduling, traffic scheduling, admission control, resource reservation, like that. Different techniques are there in the case of quality of service. So here we will see some of the technique that will be useful for understanding this technique of the improvement of the QoS. The one is we will see about is the scheduling. So under the scheduling, what is that a packet from different buffers, it will arrive at the arrives at the routers. that is what we see from the different buffer. It will arrives at the router, and that router will process it, and a proper scheduling will treat for the different flow in a fair and appropriate manner. That is, from a different buffer, it is not made to flow at a same instant, otherwise it will have a congestions. So if it is made to flow in a different intervals, so these type of a scheduling will try to improve the quality of service. So here one of the technique is a FIFO queuing. FIFO means first in first out queuing. So you can try to see the packet is arrives in this one, and this is a buffer in which the packet will come and place, and once from this buffer it will be sending to this side. If buffer is full, then the packet is dropped, otherwise it will move to the queue, and thereby it will this queue is nothing but you can think like a switches, and if the arrival rate is higher than the average processing rate from this queue, if the packet is being sent to the processor, and if arrival rate is greater than the processor, what will happen then? The packet will not able to process. So first in first out will try to see that it will allow the packet to wait in the queue, and thereby it will try to process it. So this is what we try to see in the case of a packet queuing. So here in the packet queuing, buffer is one place. If excess is there, it is stopped, otherwise it is moved to the queue, and from the queue it is being processed one after another, and thereby based on the capacity of the processing, the processor will try to deliver. So this is known as a first in first out queuing. There is another method is there, that is a priority queuing under the class of a scheduling. So in the case of a priority queuing, what is that? Every packet is assigned a priority class. So here you can see that it is exactly like this way, but it has a different forms. Packet is arrived in a classifier. It will classify into two patterns. One is the highest priority and the lowest priority. So that is what this same thing is appearing here, and based on the priority, the processor will try to decide. So that is, it is a switch which turns to the other queue when the current one is empty. That means after processing this one, it will go to this one. That means this is the highest priority, so the processor will first process this one, thereby it will try to consider this one. So here the system does not stop serving the queue. So the whole of the queue is being processed based on the priority index. And priority queue, actually it provides a better QoS than the FIFO queue, and because of the high priority for the multimedia, thereby the destination will find a lesser delay, and there will be a continuous flow in the high priority queue, and the packet with the lower priority will never sometime will find it difficult to not to process. So sometime this lower priority queue may enter into starvation conditions because it will be waiting for it. So this is known as a priority queue. Now there is another type which is coming under scheduling is a weighted fair queuing. So in the weighted fair queuing, if you try to see this one, it is being given a weights. So this is a better scheduling methods. In this technique, the packets are still assigned a different classes and admitted in the queue, and based on the weighted queue on the priority of the queue, highest priority will be given the highest weight, and the lowest priority will be lowest weight, and even the system sometime use in a round robin fashions here. That is also possible, so that based on the each round robin pattern, also each queue gets to process one after another. So these type of things is possible in this case also. Turning, which switch will select 3 packet from the first queue, then 2 packet from the second queue, and then 1 packet from the third queue. So thereby based on the weights, that those number of packet can be processed by the processor. So we that's why weighted queue find its more or a better scheduling methods. Now coming to the another area is about this scheduling is with respect to the is about traffic scheduling. So this is traffic shaping. Traffic shaping is the second type. That is what we try to see across this. This is a traffic shaping. For not you can turn this one. This is not a scheduling. Traffic shaping in this case. Now under the traffic shaping mechanism, it controls the amount of the packet and based on the traffic. So that's why this is a traffic shaping. In place of this scheduling, you can eliminate this particular ignore this word by traffic shaping. Now there are two methods there under traffic shaping. One is leak bucket and is a token bucket. We will discuss about this in the our next video series. However, here in this leak bucket sharing, you can try to see this one. Packet arrives here. When the packet is when this buffer is full, packet will and it will, if it tries to overflow, then it will be discarded. Otherwise, it will go to queue. After reaching at the queue, this packet will be processed one by one based on the condition of this leaky bucket algorithms. So at a constant rate, it will be processed by the processor, and thereby the packet will be delivered. That means this is how the packet is being shaped, or the shaping algorithm of the or the control or the flow of the algorithms can able to maintain. But in the token bucket forms, what is happening? It is exactly in the same way that the packet is arriving. When it is full, it is discarded. Otherwise, it is coming into the queue. Once it comes into the queue, then based on the token condition, this packet will be processed. That means when the packet is arriving, which is need to be processed, a token is selected, and one packet is moved, and that token is dropped. The next packet is which need to be processed. The next token is taken, and that is being dropped, and then it is being processed. That is, one token is removed and discarded per cell is transmitted. So like that one, suppose here 1, 2, 3, 4, 5, 6, 7, 8. So if you have a counter of 8, means 1 by 8, 8 times you are dropping the packet. In that rate, the processor will able to process. That means how much time it need to select the token and to throw that or the discard that token with respect to the flow through the processor determines the amount of a traffic that need to be processed over over that network. So this is what we try to see in the case of a token bucket and the leaky bucket. So these are the two different type of algorithm that is used for the traffic shaping. So that is what we try to see in the case of a technique for the QoS. In the case of a admission control, we have tried to seen in the case of a admission control is that the amount of a traffic that need to be admitted should determines based on the number of traffic that is there in the network and how it has to be controlled. Resource reservations, when we talk about a resource reservations, it will try to see that how much amount of a traffic that has to be put under the reservations conditions. Thereby it can able to process that particular traffic so that the congestions can also be avoided and the QoS can be able to maintain. So scheduling of the packets, that is one type. Another type is the traffic shaping of that one, and how many traffic has to be admitted at the point, and how many amount of resources we are putting under the reservations conditions, so that it can able to process the entire network in a appropriate manner without creating a congestions. So this is what we see under the QoS. So the QoS conditions, it will has its goal is that it has to guarantee that the network can be delivered in a predictable manner, and it will able to perform the availability, bandwidth, latency, and error-free conditions to a optimum conditions, so that thereby the characteristic of a network's conditions can be maintained to an extent. So with this we stop discussions with respect to the quality of service here. Thank you.